Good morning, students. This is Dr. Eustace Russell, working as Assistant Professor, the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So far, we are seeing the subject called Engineering Mechanics, subject code ME25C02, under the regulation of 2025 for the second semester for the first year students for the Department of Robotics and Automation. So far, we have completed 2 lecture videos in the unit called Friction. Various laws we have seen, coefficient of friction definition we have seen, various conditions, limiting friction conditions, static friction, dry friction, kinetic friction, everything we have seen. Today we are going to see some important topic called wedge friction in this topic. So what is that wedge means? Before go on to the problem, we must know that what is wedge. Wedges are small pieces of materials with triangular or trapezoidal cross section. They are generally used for lifting heavy weights, for slight adjustments in the position of a body, etc. So it is a small piece, a triangle piece, for lifting the heavy blocks. We are using this kind of cross-sectional materials. Weight of the wedge is very small compared to the weight lifted. One advantage is that weight of the wedge should be light, but it will be used for lifting the heavy blocks. Hence, generally the weight of the wedge will be neglected. Therefore, the wedge weight will not be taken into account in most of the cases. Here we can see one wedge is there, one block is there in the upward, one small line section it is given. One force that is acting towards the left hand side, that is force P to the wedge block. Now what will happen? Automatically the weight of the block will move in the opposite direction. In the second free body diagram also we can see the weight of the block W is acting in the downward direction. Why the mu R is acting downwards? That is a frictional force for the block. So automatically it will move upwards. The friction will move in the downward direction. So why? What is this R1? We have a contact with the any surface. Therefore, the normal reaction will be acting over that. For the wedge also, we have to write the normal reaction, that is normal to the plane. That is important. Now, what is the friction? The direction of motion of the wedge is towards the inside of the block. It is moving in the downward direction. So automatically the frictional force mu2 R2 also given in this same direction only, because the force that is acting over there. So now one basic problem we will see, not a basic problem, this is an important, that is part B questions. For the 12 marks questions, this kind of wedge type problem mostly the university will ask. The student must be familiar. To draw the free body diagram is must. What are the free, how many drawings you have to draw for this problem? Means 2 free body diagrams is must for that. One is for wedge and another one is for the weight of the block. That is important. 2 free body diagrams must to solve these kind of problems. Without free body diagram, it's very difficult to solve the problem, and various relationship data also you have to get from the diagram only. The first thing, find the horizontal force P on a 10-degree wedge shown in figure to raise the 1500 Newton load. The coefficient of friction is 0.3 at all contact surfaces. So it is the value of COF is given as a common value. There is no need to change the value. It's a common one. The picture representation is given over here. The left hand side of the diagram it is given, and the right hand side is a free body diagram. The various forces that is acting, external forces. The R1 which I told already, the downward, that is 0.3 R1 is the frictional force, and that downward arrowhead represents the 1500 Newton acting in a downward motion. Then this wedge also the same similar manner. Automatically 0.3 R2 is acting over there, the frictional force. Then R2 the normal reaction force with a 10-degree. Now we have to resolve the forces horizontally first of all. Now what will get? R1 minus 0.3 R2 cos 10 minus R2 sin 10 degree equal to 0. Upon simplification, you will get R1 equal to 0.47 R2. Resolve the forces vertically. R2 cos 10 degree minus 0.3 R2 sin 10 degree minus 5500 minus 0.3 R1 equal to 0. Upon simplification, you will get R2 equal to 1894.63 Newton. Then for the wedge, that is for the block we have seen. This is for the wedge. Resolve the forces vertically. What you will get means R3 plus 0.3 R2 sin 10 degree minus R2 cos 10 degree equal to 0. Therefore, upon simplification, you will get R3 equal to 1767.15 Newton. Then again resolve the forces horizontally. You will get 0.3 R2 cos 10 degree plus R2 sin 10 degree plus 0.3 R3 minus P, the force, that is P equal to 0. Then you will get the applied force is nothing but 1418.9 Newton. This kind of another one problem, one symmetrical type of problem. That is one block is there and the two wedges are there. It is a symmetry. We can take for one wedge in the left hand side we can take first of all, then we can do for the right hand side wedge also. The first of all, the two wedges A and B are used to raise another block C weighing 1000 Newton as shown in figure, assuming coefficient of friction is 0.25 for all the surfaces. Determine the value of P for impending upward motion of block C. The whole block is there. For that, we are going to draw the external forces as a free body diagram. The first we can see that. So what is that? 0.25 R and 0.25 R. Then 30 degree it is given because it is 120. That is the wedge will be in 30 degree. Then here also the two reactions will be acting R. Then the separate wedge we took separately and we are drawing the free body diagram. One reaction will be there R with a 30 degree and 0.25 R because mu R, that is 0.25 R. In the lower side we have a normal reaction R1 and 0.25 R1 is also there because the frictional force is moving towards the right hand side automatically. The direction of motion of the wedge is towards the right hand side, automatic friction force is towards the left hand side. That's why the lower side of the line that is mentioned in the left hand side 0.25 R1. R1, the symbol R1 that is mentioned in the upward direction is the reaction force, normal reaction. Now we can see that because of symmetry, the reaction at all contact surface between A and C will be 1000 Newton, same as between B and C. Now it is a symmetry only, therefore we are taking the reaction will be as 1000 only, similar. Now we are taking, let this reaction be R, equilibrium of block C. Again you are taking the block C, solving the forces vertically, we will get R cos theta, R cos 30 degree plus R cos 30 degree minus 1000 minus 2 into 0.25 R sin 30 degree equal to 0. Upon simplification, you will get R equal to 674.74 Newton. Then equilibrium of the wedge A also we are going to take, resolve the forces vertically. Then we have to resolve the forces vertically to the plane. What are the forces means? R1 plus 0.25 R sin 30 degree minus R cos 30 degree equal to 0. Then you will, upon simplification, you will get R1 equal to 500 Newton. Then resolve the forces horizontally along the plane. Therefore, P minus 0.25 R1 minus 0.25 R cos 30 degree minus R sin 30 degree equal to 0. Then when simplifying this relationship, you will get the force will be 608.46 Newton. This is the free body. For your understanding, last slide also I have mentioned the free body diagram. Kindly note down. Next problem, the previous problem, one problem that is we took the wedge that is acting in the horizontal direction. This is somewhat different. The same kind of problem, but the position of the wedge and the block has been changed. Now we can see this. Two blocks A and B are resting against a wall and a floor as shown in figure. Find the range of value of force P applied to the lower block for which the system remains in equilibrium. Coefficient of friction is 0.25 at the floor and 0.3 at the wall and 0.2 between the blocks. Now we can see we are going to write for the 1000 Newton first. These are the various free body diagram. R1 reaction will be from the wall. Then why this point 0.3 R1 is moving upward means block is going downwards. That's why the frictional force in the opposite direction. Similar thing, 0.2 R2 also will be in the opposite direction. Then R2 is the reaction one. Similar for the 500 Newton also, we have drawn the FBD, that is free body diagram. R2 0.2, that is mu 0.2 R2 is moving in a downward direction. 500 Newton is acting downwards because of the gravity. R3 is normal reaction because it have a support with the horizontal surface. That's why R3. Then movement, that is 0.25 R3, frictional force, and the applied force also mentioned in the diagram, that is P, capital P. Now various conditions and resolving the steps which I mentioned over here. The first thing, consider the equilibrium block A. Resolve the forces vertically first of all. Resolve the forces vertically as you have done what you have done in the previous problem. The same procedure will be followed again. Resolve the forces horizontally also. The same procedure will be followed. Then substituting this value of R1 equation 1, you will get R2 equal to 1107.66 Newton. Then 673 R2 equal to 1000. Take it as equation 1. And we are going to consider the equilibrium of block B. Resolve the forces vertically. Then R3 minus 500 minus R2 cos 60 degree minus 0.2 R2 sin 60 degree equal to 0. Upon simplification, you will get R3 equal to 1245.68 Newton. Then horizontally, we have to resolve the forces. You will get R2 sin 60 degree minus 0.2 R2 cos 60 degree minus 0.25 R3 minus P equal to 0. When simplification, you will get 537.05 Newton. So this free body diagram which I mentioned in the previous slide, again I combined together and I have highlighted here. Then for the block B, again we have to take the block separately and take the forces horizontally, take the forces vertically, then apply and base the substitution, put the substitution in the equation, then you will get R2 equal to the value 27 Newton. Then equilibrium of block B also, taking the forces vertically, you will get R3 equal to 9337.8 Newton. So this is the reference which I used to prepare this content. Kindly go through these references, students. Thank you all for your kind attention. We successfully completed wedge friction under the topic of friction. In upcoming classes, we will see mainly the ladder friction. That is very important. So we will meet in the upcoming lecture video. Kindly subscribe this video, share this video to your friends. Thank you all.